Seventh graders, let's go ahead and work this out. It says 6.2, describe the likelihood of the event given its probability. You randomly guess the correct number of a multiple choice question 1 out of 4 times. Well, that's very unlikely that you're going to go ahead and get the right thing, right? So, unlikely. 1 out of 4 is not a high percentage. And that's because you're only getting it right 1 out of 4 times. Number 2 is for you to do. Number 3, find the annual interest rate. Well, remember we're going to use I equals pretty for this. So I'm just going to work my stuff over here. I equals PRT. We know that the interest is $16, so we're going to put that over here. The principal is $200. And the years is 2 years. So we're looking for the rate. I know that 200 times 2 is 400. So I can change this to 400R. Equals 16. I know to get 400 away from R, I'll have to divide it away. Whatever I divide from one side, I divide from another. Now I got 16 divided by 400. I'm going to do that math over here. 16 divided by 400. Remember my decimal's here. So I'm going to have to add a 0 here. That still won't be enough. So I add another 0. 400 does go into 1,600. It goes into it 4 times. So this would be a 0 and a 4. So I got 0.04, right? And to turn 0.04 into percent, just so we're clear with that, I do take and multiply by 4. 0 times 4 is 0. 0 times 4 is 0. 4 times 4 is 16. So I do get 1,600. And now I can say that I have 1,600 minus 1,600. So the answer is 0.04. When I move my decimal 2 places to turn it to a percent, that tells me it's 4%. So the answer to number 3 is 4%. Number 4 is for you to do. I'm going to do number 5. Tell whether X and Y are proportional. All right, to do this, I have to make sure when I divide Y by X, I get the same number every time. 8 divided by 1, well, that equals 8. 24 divided by 3, well, that equals 8 as well. Now we have 75 divided by 9. This might be a little harder. I can tell you right now, I happen to know that 72 divided by 9 is going to be 8. So this tells me I'm not going to go ahead and get 8 here. It's going to be 8. And then we're going to have, if I divide this by 9, 3 left over. So that would be 3 over 9, 8 and 3 over 9. Okay, which is really 8 1/3. That would equal 8.3 repeating. All right. So no, this is not proportional, and I'll simply say no. So the answer to 3 was 4%. The answer to 5 was no. And just so we can see this clearly, I'm going to erase all that work that I did. Let's go on to number 7 now. Number 7 says, use the bar graph below to find the relative frequency of the event. So when I use this bar graph, they're saying spinning of 6. Well, 6 comes up looks like 7 times, right? So that's going to be 7 times. Remember, relative frequency is the number of times happens over the total. Now we have to count up all these times, right? We're talking 8 plus 6, that's 14. 14 plus 9, that's going to be 23. 23 plus 11, that's going to be 34. 34 plus 9, I'll get a little trickier. 34 plus 9, that's going to be 43. And 43 plus 6 will be, 43 plus 6 is 49. I'm going to double check my numbers because it will mean a lot here. So let's try this again. We got 8, right? I'm going to do my work over here. 8 plus 6, I know that's 14. Then I'm going to take this number, which is 9 plus 11. And I know 9 and 11 make 20. All right? And then I'm going to take these two, which are 9 and 7. And 9 and 7 make 16. And I can see I made a little error there in my first one. At least it looks like it. 4 and 6 make 10. Carry the 1. That's 2, 3, 4, 5. Looks like 50. And now I got to recount again to make sure. First time I said 49, second time 50. I know that 8 plus 6 is 14. That check's good. And I know that 9 plus 11, that does make 20. So that's good. And I know the last two numbers are 9 and 7. And 9 and 7 do make 16. Okay, so we got 7 out of 50 then. Right? So I have to find the relative frequency. I got to take 7 and divide it by 50. Well, I could also just multiply the top and bottom by 2, right? And that tells me I'll have 14 over 100. And that tells me right there that it's going to be 14%. All right, let's try number 9. Spinning a number less than 3. Wow, spinning a number less than 3. Well, that means I can spin a 2 or I can spin a 1, right? So that means, hold on a second, spinning a 6. Oh, that was 7. Good. Okay, I thought I might have messed up there. Not less than 3. That means 8 plus 6. That's 14. So, oh, that is for me to do. 14 out of 50. And again, I can go ahead and use the same thing I did before. I can multiply both of these by 2. I could have taken my calculator, 14 divided by 50, just showing a different way of doing this. And this will give you 14 times 2 is 28, and 50 times 2 is 100. So that's going to equal 28%. I know this because whenever I have 100 on the bottom, it's 100%. So 28 out of 100 is 28%. 10 is for you to do. 11 is mine, spinning a 1 or a 3. So a 1, there's 8 possible ones, and a 3, there's 9 possible ones. Well, 8 and 9 make 17. So this is 17 out of, oh, sorry, this one, 17 out of 50. Scratch that out. And again, if I do this, I can multiply the bottom and top by 2. And that's going to give me 34 over 100. And that's 34%. Now, could you say, yes, I'm going to go ahead and take 17 and divide it by 50? Yes, you can. You will get 0.34, and you'll have to remember to move that decimal over 2 places. Just like over here, 14 divided by 50, you will get 0.28. You'll have to move the decimal 2 places. 12 is for you to do, so I'm off to do number 13. and there's 14%. Just like I said, 28% and 34%. Let's just erase all the gibberish so you can see it clearly. Now I'm going to go do number 13. It says that your friend uses the bar graph above to find the experimental probability of spinning a 4. All right, spinning a 4 would be 11, and that's 11 out of 50, right? All right, is your friend correct? He says there's 6 possible outcomes. And it says graph define experiment probability of spinning a 4. It doesn't say nothing bigger than a 4. And he said there are 6 possible outcomes. Okay, so the experiment has a probability of 4 is 1 over 6. Let's look at 4 one more time. 4 has, looks to me like 11, right? So spinning a 4, I would imagine, is really 11, that's 22%. I would say your friend is wrong. It says, no, your friend found the theoretical probability. And theoretical probability is, since the number 4 is one number out of 6, right? One number out of 6, that would be 1/6, but that's not what we did here. We did here was the experimental probability. All right, 14 is yours to do. Find the probability. Use the spinner to find the theoretical probability of the event. So spinning red, there's 2 reds, so that would be 2 out of 6, and that's 1/3. So I would say 1/3 is 1 divided by 3, or 33.3%. Really should be 0.3 repeating percent, but they rounded it up here. 16 is yours. 17, spinning an odd number, where there's 1, 2, 3 odd numbers. So that's a 50% chance, right? 1/2, which is about 50%. And then there's number 19, spinning a number less than 7. Well, all these numbers are less than 7. So that's 100% chance that we're going to spin a number less than 7. 100% chance, or the number 1. 21 says each letter of the alphabet is printed on an index card. What is the theoretical probability of randomly choosing any letter except for Z? Okay. Well, all the letters except for Z would account for 25 out of the 26 letters. 25 divided by 26 is 0.962. We move the decimal over 2 places, and that's going to give me 96.2%. All right, let's go ahead and get to number 20. Oh, looks like I left all the answers here, but I'll go through them anyways. 23 says the bar graph shows the results of this of spinning the spinner right here 20 times. So 1 came up 3 times, 2 came up 2 times, 3 came up 6 times, 4 came up 4 times, and 5 came up 5 times, okay? Compare the theoretical and experimental probabilities. Well, 23 says spinning a 3. Spinning a 3, that would be 6, right? And we have to count up, remember there's 20 times that we spun it. So that would be 6 over spinning a 3, I'm sorry, yeah. 6 over 20. Theoretically, since there's 5 numbers here, there's a 1 out of 5 chance. But experimentally, remember we said 3 out of 20. And 3 out of 20, oh, I'm sorry, 6 out of 20. I don't know where I got 3 from. 6 out of 20. 6 and 20 are both divisible by 2. And that's going to equal 3 out of 10. Now you know where they got the 3 out of 10 here. And 3 divided by 10 is 0.3, or 30%. Okay? So this equals 0.3 in your calculator. And you move it over twice, it becomes 30%. All right, for number 25, spinning an odd number. The odd numbers are 1, 3, and 5. So that's going to be 3 plus 6, that's 9, plus 5. 9 plus 5 is 14. So again, theoretically, odd numbers, that's 3 numbers out of 5, right? We said that. There's 1, 2, 3 numbers out of 5. That's where they got the theoretical from. And then the experimental is actually, and we said 14, right? Out of 20. And again, we could divide both the numerator and denominator by 2. And that's going to equal 7 over 10. Did we have to do that? No. Because 14 divided by 20 is still 0.7. And then you'd move the decimal over twice, that'd be 70%. All right. I think it's time for us to go ahead and work number 27. Sorry, I'm having trouble finding my arrow. If you could bear with me, I'm sure it's going to come back in a second here. If I didn't run out of power on my mouse. There we go. All right, so that's why it wasn't doing it. I had to come over here and put it back to arrow. Good. All right, so here we go. Going to number 27. Should you use theoretical or experimental probability to predict the number of times you will spin 3 in 10,000 spins of the spinner for exercise 22 through 25? Should I use theoretical or experimental? Well, theoretical, really. Using experimental probability would be very time consuming and to the spinner, especially when you're doing it 10,000 times. Okay, who wants to spin that thing 10,000 times? All right, let's go to number 29. It says here, comparing theoretical probabilities, I'm going to use less than, greater than, or equal to compare the theoretical probabilities to selecting cards from a standard deck of 52 playing cards. So the probability of getting an ace or the probability of getting a club. The probability of getting an ace is 1, 2, 3, 4 out of 52. But the probability of getting a club is what looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 out of 52. So I would say this is going to be, aces will be less than, right? Less than the probability of getting clubs. 30 is for you to do. Now it says hearts and diamonds. Well, the probability of getting a heart is 13. The probability of getting a diamond is 13. I would put equal to because they are the same amount. All right, number 33 or 32 is for you to do. 33 is mine. There are 8 females and 10 males in the class. What is the theoretical probability that randomly chosen student is a female? Well, the theoretical probability is going to be 1/2 because it could be male or female. So they're saying, see, there are 8 females and 10 males. Oh, so this is, what is the theoretical probability that a randomly chosen student is female? I would think that's 8 out of 18, right? I know what you're thinking. Where did they get the 9 from? I'm going to explain that really quick. Remember, there's 8 females and 10 males, so there's 18 kids altogether. And they said of getting a female, that was going to be 8. I really thought theoretically they would say 50-50, but they're talking about from this amount of people. So now we're talking, divide both of these by 2. And again, you don't have to. 18 divided by 8 is going to give you 0.4 repeating, okay? But when I do this, I get 4 over 9, which is really going to give me the same thing because it's the same ratio. And 4 divided by 9 is also going to give me 0.4 repeating, okay? And when I move the decimal over twice, that's 44. And then I'm rounding up because 4 over here is going to be less than 5, right? So I cross that out and leave it as 44.4%. That's what they got. B says 1 week later, there are 27 students in the class, the theoretical probability that a randomly chosen student is a female is the same as last week. How many males joined the class? We're going to go with 5 males. Okay, they're going to say 5 males. Let's compare that for a second. The ratio is 4 to 9. Okay, and we said that it's now 27. We had 18, right? So we had 9 more join, right? 9 more. So if this theoretical probability was 4 females for every 9 students, that means for every 9 students, there's going to be 5 males, right? So because this was 8, and remember this would have been 10. I'm just going to work it out because I know that's going to be a little confusing to people. 10 males out of 18, right? And now if we wanted to, we could even do cross multiplication. I'm going to work it this way first. Is going to be equal to, again, this would be dividing both by 2. Five over 9. Everyone see how we got that? And so if we're adding 9 more kids, 5 of them will be male. The other way you could have done it is to cross multiply. You would have got 10 over 18 for males. And since we have 27 kids now, we would look for X, the number of males. This would give me 10 times 27, and that's going to give me 270. Has to equal 18X. I divide 18 from both sides. 270 divided by 18 is going to give me, let's see, the total is going to be, let's see, 15? Yes, 15. And remember, since only 27, how many males joined the class? If there were 10, then only 5 more joined the class. Okay? 34 is for you to do. 35 is an open-ended question. I'm not going to have you do it because it's asking you to describe a real-life situation. 35 is omitted. Do not do it. Okay, that's just a sample answer. 36, looks a little too hard for you. I'm just going to go ahead and say that going up to number 34 in our homework is good enough. We're going to stop there, okay? So stop at number 34, and I'll see you in